You might be wondering, what am I holding in my hand? This little guy right here controls phones, cars, rockets, and even this camera. This is an integrated circuit. So, about the name, we have integrated and circuit. What is a circuit? A circuit is a closed loop electrons can travel through. Electricity cannot flow without having a complete path. So that's why we have our circuit. And then what does integrated mean? Before, engineers would need to just wire all of these electronic components together, and it would be a lot. It would be messy. Devices would be huge. Devices would be very expensive. What if I told you that now we have this guy that can just compact all of those little components in one little package or one little chip? That is an integrated circuit. It is built in, or it is integrated with all of these electronic components together in one tiny chip. Now that we understand the big ideas for integrated circuits, let's understand the types of integrated circuits. Well, there are digital ICs, and digital just means that we have discrete values. Discrete as in just these distinct things like on or off. Or for example, binary. Computers communicate binary, 1 or 0. Or we could even deal with some logic, like true or false. Digital integrated circuits use logic gates to make decisions. Take for example a light bulb, or a more fun way to put it, this bird. So, it might be the case that there is a logic gate where this digital integrated circuit inside is determining whether all conditions are safe around and if the user has flipped on a switch or has inputted something like touched it. So if I were to input logic gate decision maker, if I touch this, a light should be on. And if I touch it one more time, decision is resulting in an off. So as we can see, these digital integrated circuits are awesome for computers because they are making decisions, and they can communicate with binary because they have that discrete value perspective where they can have a 1 or 0, on or off, just as computers communicate with those binary 1 or 0s. So now I want to talk about analog ICs. Analog ICs process continuous voltages or currents that represent real-world quantities like light, temperature, sound. We got all of these continuous waves. I mean, in the real world, a lot of signals, or what carry information, are going to be continuous instead of discrete values. Discrete is awesome. I mean, digital, we got that for computers because how they communicate is via binary. They communicate in 1s and 0s. They communicate with logic that allows us to perform certain executions, that allows to perform certain processes that we can, let's say, have some code, give it, and convert it to 1s and 0s, or ultimately compile it. So that's an awesome skill. But now, let's say we're dealing with sensors. How is motion? How far away is my hand from this camera? And you're detecting it. Maybe the closer I am to the camera is a higher voltage, and the farther away I am from the camera is a lower voltage. Now this voltage is constantly changing as I'm constantly sensing. Everything is continuous, so thus we have our analog ICs. It's continuous, just that comes up in the real world a bunch. And so now, what if I told you, an example could be like a light dimmer. So, how we had last time just the light bulb where we have discrete values either on or off. Now we can have a light dimmer where we have a whole variety of ways to turn this light into brightness or into dimming, depending on how high a voltage is or how low a voltage is. So we have endless possibilities there. Examples of where analog signals are used could be in a volume knob. But what if I told you we can have both continuous and analog? Boom. That right there is a mixed signal IC. Mixed signal ICs, they just combine analog and digital circuits into one whole package. Isn't that awesome? And a lot of the ICs in a real world have that mixed signal. For example, we got the Arduino. So our Arduino overall, this is our development board. Inside we have this microcontroller, which is a type of IC, and in this specific type of IC we can handle digital. That's why we got here labeled digital. And we can also handle analog. That's why we got here analog. Let's say your phone, let's say I tap on the phone, and whenever I tap, like I'm just gonna go pop. That is sensing like where I touched on the phone. And then, so that's my analog. And then my digital will be like, okay, now what program can I execute? Given all of these ones and zeros that I know, all these discrete values, which ones can I turn on? Which zeros can I turn on? Or which ones can I turn off? All of that combined to make one performance. That sounds awesome. But how can we make that possible? I mean, analog, digital, those are two separate things, aren't they? Well, that's why we have converters. We have digital to analog converters, or we have analog to digital converters. Like we can start off with the analog to digital converters, and those are called ADCs, abbreviated, right? Analog to digital converter, ADC. You are just getting those analog signals and turning them into these discrete values. And the reason why is back to that phone example. In order for the phone to really understand, how am I gonna open up an app? How am I gonna change the brightness when this user swipes down or swipes up to increase the brightness? You know, all these performances are going to be via digital, right? All these ones and zeros after compiling when you make some awesome code. And then your analog is going to be continuous, in which it senses, you know, what you touch, where you touch on the phone. And then that analog signal, or those signals overall, get converted into digital values. So we have that analog to digital conversion, or ADC. And we can also have digital to analog conversion. So maybe we have our motors, you know, robotics, we're converting whatever code we have into a whole analog signal, because we're trying to control how fast we want the motor to be. Let's say how fast it is determined by like numbers 1 to 10, and 10 is like the fastest. What if I put it at 8? So I'm going bam, go fast, go fast, go fast. You know, my computer's gonna send all of this binary and say, okay, I want it at this level high. But how is the motor gonna know how fast to go? Like with analog, right, continuously? Well, we will convert the digital to analog. DAC, digital to analog converter. So now, I hope you've appreciated the essence of how this is really in our modern technology, our phones, our tablets, or whatever smart devices that we have. And it's just so interesting to know how all of these components go together overall, because this represents the essence of hardware and software combined to make awesome products. Thank you for listening. Have a good day.